But can you still hear me? Manaling tingog. Sige, so let me share my screen. So this morning, what we are going to discuss is about the analysis of one-dimensional bars. So for matrix analysis of structures, I would say this is most important because this one serves actually as the basis of, I would say, the principle in matrix analysis of structures. So we're going to discuss here the very foundation of how we do matrix structural analysis. So if you fully understand how to analyze one-dimensional bars, I don't think it's difficult to analyze other types of structures. So other type of frame structures like trusses, maybe frames, because basically it boils down to only one basic principle. Okay, and that's what we are going to discuss here. And then let me ask again if you can hear my voice. Okay, ba? If we can continue discussing this. Sige, so again, this morning, it's about analysis of one-dimensional bars. So now, we have to discuss this first few introductions. So in matrix analysis of structures, there are two possible formulations. So I think we have discussed this also in the previous meeting. There are two possible formulations if we do matrix analysis of structures. The first one is the force method, or sometimes known as the flexibility method. Now, in this method, it's the forces that are unknowns. And then the second possible formulation is the displacement method, or more commonly known as the stiffness method. And in this method, it uses the displacements as the knowns. So I believe I have already emphasized this, that mass advantageous ang stiffness method compared to the force method. Okay? Very straightforward ang yan process. So in the displacement method or this stiffness method, displacements again are the unknowns. And in this method, we deal with the kinematic indeterminacy rather than static indeterminacy. So take note, kinematic indeterminacy is different from static indeterminacy. What we have learned in our theory of structures, that was about static indeterminacy. So if you recall, we can easily determine if this structure, a beam, for example, if this is indeterminate to second degree. So that means the number of unknown reactions is more than the number of available equilibrium equations. So it's pretty simple. So we need, let's say, the number of unknowns is 5, and there are only 3 um, available equilibrium equations. So that makes the structure indeterminate to the second degree. Okay, so what we need is we have to find another at least 2 equations, okay, to solve the unknowns. Right? So very simple rule in algebra. So the same number of uh, equations needed to solve the unknowns. Okay, you should have at least the same number of equations to the number of unknowns, so you can basically solve the unknowns. Okay, but what that kind of indeterminacy is static indeterminacy. So it's different from kinematic indeterminacy. So in matrix, what we are dealing here is not the static indeterminacy, but the kinematic indeterminacy. So in this method, the formulation of the problem is very, very simple. Okay, so getting matrix para na ako sa'yo nagagayin siya, no? Only that we will be dealing with large equations because we will be dealing with matrices. Now, as emphasized again in the previous meeting, so most if not all of the commercially available softwares are using matrix method, particularly the stiffness method or the displacement method. Now let's go back to the level of indeterminacy. So again, as mentioned a while ago, what you have learned so far learning indeterminacy is about static indeterminacy. So that was what you have learned from your theory of structures. It's simply equal to the number of unknown reactions when you subtract the number of equilibrium equations. Okay? And of course, to solve the equations, you need the compatibility equations. Okay? So static indeterminacy also refers to the number of compatibility equations needed to solve the problem. Now, on the other hand, when we say kinematic indeterminacy, this is equal to the number of degrees of freedom. So this is, I would say, many of you are not familiar with this term, degrees of freedom. So when we say kinematic indeterminacy, this is simply equal to the number of degrees of freedom of the structure minus the number of restraints present. Okay, so as far as the restraint is concerned, I think all of you are familiar with this. So what I'm going to expound further is this term, degrees of freedom. So when we say degrees of freedom, na degrees of freedom at a given node is equal to the number of possible displacement at that node. Okay? So it's again the number of displacements at that node. Now, in other words, it is dependent on the type of structure or element that we are dealing with. So now if we consider to the simplest form of structural element, which is a one-dimensional bar, so ang movement ng one-dimensional bar is only on one direction along the axis of the bar. So that means since it's only one direction, it's on the axis of the bar, so it constitutes only 1 degree of freedom if it is a one-dimensional bar element. Now, if we consider a truss element, a two-dimensional truss, for example, so each node will move into two principal axes, no? So an X and the Y axis. Okay, so that makes the number of degrees of freedom per node or per joint to 2 degrees of freedom. Okay, so nakakay translation on the X principal axis and another translation on the Y principal axis. Two-dimensional beam, for example, so kung beam ka, ang node mo nakakay translation along the vertical axis, and there is also now a rotation na naman kay moment if it is a beam. Okay, So the number of degrees of freedom for a two-dimensional being is 2 per node. If it's a prime element, there are now 3 degrees of freedom per node. Why? Because you now have the translation on the horizontal axis or the x-principal axis. Okay, so that makes 3. We have the x translation, the y translation, and we have now the rotation. Okay, because we have again the moment. Okay. Now let's discuss the definition of stiffness. So this is very important kasi if you really want to practice structural engineering, this one term also nga dapat ma-embed sa inyong system. Okay, so stiffness is always um, associated. No? So basically all structural elements, even the entire structure is always associated with this term stiffness. So my definition when you say stiffness, let's consider first a linear spring. So usa ka spring, no? So linear spring meaning in one direction lang siya. Okay, one-dimensional spring. So in strength of materials, you have learned that this basic equation. So force is equal to K times X, the displacement. K is what we call as the spring constant, or also termed as spring stiffness. No? So kaning K. So kani is the displacement. No? So sometimes, depende sa inyong sa atong strength of materials, pwedeng P, stiffness, and we have the displacement. So basically, this one is the same na siya, no? So F stands for the applied force, K is the stiffness or the spring constant, X is the displacement. Now, by considering this basic equation, it is safe to say that this K, which is the spring stiffness, is equal to F over X. Or simply, this is equal to the force when X is equal to 1. Right? So, K is simply equal to the force that corresponds to a unit displacement. Meaning, when the displacement is 1, your K is just equal to the applied force. So that is simply the basic definition of stiffness. So if we consider an entire structure, a building, for example, it is, if we try to simplify it, no? So the building is simply nothing but just a big spring. Okay? So na kay stiffness, you apply a force. Then you have also the displacement. So if you have a lot of stiffness, okay, so if you have a lot of stiffness, your displacement would also be reduced. Okay, so that is why stiffness is really very important. No? So, di ba, mingon ka displacement nimo X, equal mo sana siya to F over K, right? Meaning, the larger the value of K, given a value of force, let's say, for example, an earthquake force, okay, so you need the value of K, you need to increase the stiffness in order to reduce the displacement. So that very simple analogy, no? So very basic principle, no? Okay, so at least you have learned something, no? So the building is simply like a very big spring. Now, if we expand this to matrices, muna na siya, matrix man yung atong subject, so we will be dealing with matrices. No? So, kung ato ni siyang i-expand into matrices, so ang atong force karon, so in matrix form, ang K na to which is the stiffness, is also in matrix form. And this is now our displacement in matrix form. Okay. So that is if we consider multiple degrees of freedom. Katong gini ha, kuha lang to siya, no? Kanang single degree of freedom na to, isa lang kanod ang atong consider. No? Now, if we consider a 2 degree of freedom system, kung duha na siya, so ma-2 by 2 na po ang akong stiffness matrix, no? Kamaw na po ning akong force. If we consider now 2 degrees of freedom, meaning two translations or two rotations, depending on the structural system. So this is now what we call as the stiffness matrix. And these are the elements of your stiffness matrix, which are termed as stiffness influence coefficients, or simply just the elements of your stiffness matrix. No? Okay. Again, this is the force matrix, the stiffness matrix, and this is the displacement matrix. Okay. Well, if you consider a big structure, so you have now several degrees of freedoms. So mitabo karon, let's say if you consider 100 degrees of freedom for a particular structure, ang imong stiffness matrix karon will have a size of 100 by 100. And that would be impossible to do that using manual calculations. So, of course, the computer will easily do that. So that is why this matrix is really intended for, the intent of this is really for computer application. Okay? This can be easily handled by the computer. Yeah. Now, going back to the definition of stiffness. No? So let's consider this force displacement relationship in matrix form. No? So with 2 degrees of freedom. So that's 2 by 2 size of your stiffness matrix. Okay. Now, suppose we let U1 kanisya equal to 1, kanisya equal to 0. Diba? So, diba, by definition, multiply ka aning duha. Diba? We discussed this already. No? So, by the way, what is the size of this? 2 by 2. And this one is 2 by 1, meaning 2 rows, 1 column. We start with the number of rows. Now we can multiply 2 matrices if they are conformable. They are conformable. Why? Because these two are equal. So what is the size of the resulting matrix? It's 2 by 1. Mo siya, no? Mo man ang iyang product. Diba? Okay. So to get the product, so this one is simply equal to, diba? Kani first row, first column. So it's simply K11 times 1 plus E12, okay, times 0. Of course, this one is 0. So in other words, your F1 is equal to K11. So meaning this is now the stiffness influence coefficient on the first row and first column, or simply the element of your stiffness matrix in this location, first row, first column. So now, by having this, it simply means that this element is equal to the force at point 1, okay, that corresponds to a unit displacement point 1, diba? That's the assumption. And only at point 1, meaning the rest are 0. Okay. So similarly, if we do this kind of analogy, When I say K21, it is simply equal to the force at point 2, diba? Force at point 2 that corresponds to a unit displacement at point 1 only. Okay, so in other words, akong sulbo ng force, di ba? Sa point 2 niya, butang ko og 1 unit displacement at point 1. That's how I can get this element. Okay? If I want this, I have to set a unit displacement at point 2 and I have to solve this force at point 1. Okay, and again, this element, so it should be the force at point 2 with a unit displacement at only at point 2. That is the basic definition again of stiffness. Okay, corresponds to a unit displacement. So let's continue. In general, the stiffness element Kij is defined as the force at point I corresponding to a unit displacement at J and only at point J. Okay, umingon po K52, meaning force na sa point 5 that corresponds to a unit displacement at point 2 and only at point 2. Okay, meaning the rest of the displacements are 0. Now let's have an example. No? So I would like to take note that this is just for the stiffness definition. Okay, so ang atong ipag-discuss karon is just the principles. No? So you will be guided. No? So as always emphasize, if you have this basic principle, wala lagi kay problema because pareho ra gyud ni tanan, no? Ora na buhaton ninyo. Only that we will be dealing with large matrices because as we go on, we will be dealing with large matrices because the number of degrees of freedom will also significantly increase. Okay. Now, I want you to consider this example. So, the structure below consists of 2 bar elements. So there are 2 bar elements. Okay, duha ka bar elements. So kani mo ni ang first na bar element and this is the second bar element. Okay. Well, obviously you can easily solve this using the principles you have learned also in theory of structure, even in the strength of materials. Now, the stiffnesses of these 2 bar elements are K1 for the first bar element and K2 for the second bar element. Okay. Now, these 2 bar elements are connected. So that means na kay tulo ka nodes. Diba? So, mo ni ang akong node 1, node 2, and node 3. Okay, ang akong bar 1, okay, na siya sa node 1 to node 2. Ang bar 2 is node 2 to node 3. Okay, so that means this structure na siya tulo ka nodes. Kunya, if it is a bar element, how many degrees of freedom per node? There are only there's only 1 degree of freedom per node for a bar element, di ba? Kaya usara man ni siya, amo man ni karon ang imong direksyon. Ang movement ani niya is ana lang, di ba? On one direction. So that makes every node of this bar element it has only 1 degree of freedom. So now, if we consider this whole system, this whole structure there are 3 degrees of freedom, no? So 1, 2, and 3. Kay 1 degree of freedom per node man. So that means for this structure, there are 3 degrees of freedom. So that makes also our stiffness matrix to be 3 by 3. No? So we have to expect that our stiffness matrix K no? 3 by 3 na siya. No? So K11, K12, kani K13, okay, next ani 21, K22, K23, and K31, K32, and the last one is K33. So mao ni karon ang akong stiffness matrix for this system or for this structure, no? So consists of 3 degrees of freedom. So sayon na kay ni siya kay may raman 3 degrees of freedom man. So imagine kung if this is for example a frame element, so 3 degrees of freedom per node na. So that means for this very simple frame element, the total number degrees of freedom is already 9. And your stiffness matrix is 9 by 9. That would be very difficult to solve this manually. Okay? Now, the structure has 3 degrees of freedom. So 3 translations. No? So again, we have the movements only on these directions. Okay? So 1 at its node in the axial direction of axis. Thus, we will have a 3 by 3 stiffness matrix. Right. Now, the problem here, by the way, is to determine the stiffness matrix for the entire structure. Remember the 3 by 3 matrix, no? What are the elements of the matrix? By the way, no? Para di mo malibog kay ang libutan mo nun ay K1, K2, no? Akong balik ko na ang itong K ganiha, kung inyong makuhaan sa tumatong K11, di ba, no? Narita malibog, tulad ng imong A11, no? A12, A13, okay, and so on and so forth, no? Okay, para dito malibog sa kaning K. K1 is the stiffness man sa element 1. K2 is the stiffness element 2. Whereas these values are stiffness influence coefficients or the elements of the stiffness matrix. So do not be confused with this K1 and K2. So to solve the stiffness, let us go back to the definition. Okay. So if we introduce a unit displacement at its node, 1 at a time, so meaning if I will say this is 1, na kani siya 0 ni tanan, kani siya 0 po ang iyang displacement dire, ang masolve nako nga forces karon mao na to ang akong mga stiffness elements. Okay? Yeah, at point 1 only. So F1, 1, F2, 1, F3, 1. Okay? So kadto siya nga mga locations. No? So let us introduce first a unit displacement at point 1. So kani akong himuong 1, ang iyang displacement here, 1. This one, displacements here, 0. Displacements here, 0. Okay, then I'm gonna solve the forces. Okay, so mao ni karon. So ang akong K1, ang akong F1 is equal ni siya to K1, di ba? If we are going to consider the free body diagram of this node, so it's simply K1 times delta 1. If I set this equal to 1, meaning F1 is equal to K1. So kani karon F1, then I'm considering a unit displacement at point 1. So this is now our K11, diba? Or A11, no? As uh, um, presented earlier in order not to confuse with our stiffness values K1 and K2. So this is your A11. So force at point 1 that corresponds to a unit displacement at point 1. Okay, so it's simply equal to K1. Similarly, you have to do the same, no? So if we analyze this here, masolve na sad nako ang F2 karon. Okay, so ang akong F2, if we draw the free body diagram here, it is simply equal to minus K1 delta 1, where delta 1 is equal to 1. So meaning your F2 is equal to negative K1. And this is now your K, the force at point 2 that corresponds to a unit displacement at point 1. So akong K21 is equal to negative K1. Ang K11 ako equals siya to K1. Okay? Then you solve F3. Well, F3 is simply equal to 0. So ang akong F3 here obviously is equal to 0, no? And this is equal to the force at point 3 that corresponds to a unit displacement at point 1. So ang akong K31 is simply equal to 0, di ba? Remember, if I say K21, force niya at point 2 that corresponds to a unit displacement at point 1. So meaning I have to introduce a unit displacement at point 1 and I'm going to get the force at point 2. That will be my stiffness influence factor for this location. Second row, first column. Okay. So I hope you were able to follow this, no? So after that, I have to introduce mao ni siya, no? F1 equal to K11, F2 K21, F3 K31. Mao ni nga akong discuss ganiya, K1 siya, negative K1, niya kani siya is 0. Okay? You do the same. This time you apply a unit displacement at point 2. Okay? And the rest are 0 and you solve the forces. So mauna po ni ang result na to, no? So apply unit displacement at point 2 and the rest are 0. Then we have to solve the forces. Mauna ni karon ang akong nakuha. So meaning kani force ni sa point 1 that corresponds to a unit displacement at point 2. Force at point 2 corresponding to a unit displacement at point 3 and only at point 2. Force at point 3 corresponding to a unit displacement at point 2 and 2 alone. Okay? So ingon ana siya, no? Then after that, we go to node 3, apply 1, the rest 0, and we solve the forces. So now we have the elements of our stiffness matrix. Mao na ni ang result karon, di ba? Mao man ni atong K11, okay, K12, K13, no? K21, K22, K23, K31, K32, and K32. Okay? Kana kung i-base gininyo sa definition sa stiffness. Pero what we normally do din instead of doing that, which obviously will take time, that is very tedious. So, nana tayo mga standard stiffnesses, no? Per element, depending on what type of structure. Then after that, i-combine na lang natin. Okay? But in case makalimot mo unsa ganito, then you go back to the definition. Okay? You apply a unit displacement at a certain point or a certain node. You let the other nodes to be 0 and you solve the forces. That's the elements of your stiffness matrix. That's how to get the elements of your stiffness matrix. So this is now your force displacement relationship. This is the stiffness matrix, and this is now your force displacement matrix. So, kung na kayo ipang-apply ng mga forces sa imong nodes, and you have the stiffnesses here, that means you can solve the displacements. Okay? Excuse me. And let's continue. Are you still with me, guys?
Yes, sir. Yes, sir.
Okay, now let's go to uh, another slide. This time it's about solving the displacements. So, to solve the displacements, this one is uh, the symbol of the displacement. We need to calculate the inverse of the structural matrix. So normally, may tabuan eh. This is our force displacement relationship, right? Well, kung panalize on tag structure, meaning ihatag ni ang mga forces. Okay? Then of course, you have the properties of your structure. That means you can get also the stiffness matrix. You can get the stiffness of the structure. Okay, stiffness is dependent on the properties as well as the sizes of your elements. No? The bigger the elements, the stronger the property, then obviously it will lead to a larger value of the stiffness. So from here, take note, we're dealing here with matrices. No? So the objective here is to solve the displacements. Mo nang gitawag na displacement method. No? So, itong unknowns ani ang mga displacements. Okay? Yeah. If you're familiar with the slope deflection equation, so ang kaning matrix actually is basically slope deflection equation in matrix form. Okay? So from here, ma-solve na ko ang deflection provided I have to solve the inverse of the structural matrix. Well, if you do it manually, it's very tedious, no, to solve the inverse of a given matrix, right? Okay, so you need to get the join, diba? You need to get the what's that? Determinant. Okay, and we talk about a joint. You have uh, to set up also the cofactor matrix, which involves the elements of the matrix minor or minor matrix. No? But obviously, we are using software. We can program this in computer, so we can easily get the inverse. No? Okay, so to solve this, it's simply the inverse of your stiffness matrix and you multiply it by the given forces. Okay, so that's how to solve the displacements. So ang objective gidani is solve na to ang mga displacements. After the displacements, that's the time you can solve the member forces, the stresses of your members. Okay? Oh, a while ago, I mentioned about to simplify, no, in getting the uh, stiffness matrix. It's again, if we go back to its very definition, dugay kita mo man, no? So what we usually do, nag-come up na tag mga standards depending on sa siyang element. Okay? If it's a one bar element, na natay standard stiffness matrix. Okay? If it's a truss element, two-dimensional truss, for example, we standardize already the matrix, the stiffness matrix, and so on and so forth. No? So let's start with the one dimensional bar. No? So one-dimensional bar per element, you have two nodes, correct? Usa ka bar. So na kay duha ka nodes. Yeah. The node sa one bar element, usa ka degree of freedom. So that means for every bar element, naa kay duha ka degrees of freedom. So if you have 2 degrees of freedom, what's the size of your stiffness matrix? It is 2 by 2. 2 by 2 siya. Mao niya may tabo karon. For every bar element, mao ni ang imong stiffness matrix. Okay? Now, if we consider the force displacement relationship, this is now your force matrix, this is now your displacement matrix. Now, from the basic mechanics of materials, so sa atong strength of materials, diba? So, if you recall, we already have this relationship, no? So, hopefully, i-derive sa ninyo, no? So, katong displacement equal to EL over E, diba, no? Okay. Area, cross-sectional area, this is now the modulus of elasticity. This is the applied force, and this is the length of your bar element. Di ba? Asa man ang atong stiffness na to. Di ba? Ang atong, we have this relationship, P equal to K times delta. Di ba? So, P over delta is actually your stiffness. No? From here, kung sa may P over delta ni mo, P over delta is equal to E over L. No? So, ang stiffness din mo, equal na siya sa cross-sectional area times the modulus of elasticity divided by the length. So, it is a factor of the size, the strength of your material, the modulus of elasticity, as well as the length. No? Okay? Kung taas kayong imong length, what will happen to the stiffness mo gamay? Siya. Okay? Kuhaan man siya, slender, no? Okay? So, mo ni karon, no? So, K11, going back to the definition, so it's the force at point 1 corresponding to a unit displacement at point 1 and only at point 1. So, pag-solve na ko na, mo ni ang result, no? So, it's simply K minus K minus K, and this is K. Or we can simplify it this way. Okay, that's for a one bar element. Now, if we have two bar elements, so for example, kani, imong buhaton na to solve the overall stiffness, you have to do a combination. Okay, imo ni siyang i-combine. So, let's consider this structure. In this structure, there are how many nodes? 3. 1, 2, 3. And there are 2 bars. Diba? Imo ni element 1. O kanina, element 1. Kani. Element 2. Kani. From 2 to 3. Now, stiffness for element 1, mao man karon ang atong standard stiffness na siya for a bar element. Okay, for every bar element, there are 2 degrees of freedom, so it's 2 by 2. Okay, so kaning K1, morning K1 na to, no? K1 na to, diba? Equal mo na to E over L. And this is for element 1. Okay? So meaning area 1, E1, L1. Na kaning akong stiffness sa element 2, K2, E over L. This is for element 2, no? Kaning nga mga values mo na ibutang na ko diha, no? So for element 1, so mao ni, okay, butang na nimo na E over L, no? Kani siya for 1, no? And for stiffness 2 mo po ni siya, no? This time you consider the properties of your element number 2. Okay? Now, kung saan man ako pag-combine, diba? Next, entire structure ang akong i-consider. There are 3 nodes. So that makes our K stiffness, mahimo siyang 9 by 9. Is it correct? Sorry. Per node, 1 degree of freedom. So it's 3 by 3. Sorry, no? So it's not a frame, no? So, kung size na to karon mahimo ning K11, di ba, no? Ano siya? K11, K12, K13, okay? And so on and so forth. K21, K22. Saan man ako pag-solve karon sa kaning mga values nini sa akong K. That's a challenge, no? So one way again katong gitudlo na ko ganiha, apply kag force which is dugay kayo, very tedious. So karon gamito nato ning mga ipanghimo nga standardized na nga mga stiffness matrix per element, no? So for bar element mao man ni siya, no? So for element 1 mao ni, for element 2 mao po ni siya, no? Ang ato karon saon may nato pag-combine. Okay? Now if you notice natay ipang butang diri nga mga markers. This one is 1, 2, di ba? Kay element 1 man ni siya. So this is for node 1 to node 2. So 1, 2. Kaning etong element 2, this is for node 2 to 3. So 2, 3 po, no? Mao ning markers nako 2, 3, 2, 3. So ako ditsog set na pa. Ang kaning K11, so akong buhaton is kaning mga 1-1 po ni siya, no? So 1-1. O walay lain, di ba? O K1. Okay? Kay lain. Kani siya 2-1. Wala po kay lain 2-1 diri, di ba? So except this one, so negative K1 po na siya, no? Alright? Nga kani siya is K13. Na ba kay 1-3 diri? Wala, no? So it should be 0. K21. 2-1. So 2-1. Wala po, 0 po ni siya, no? 2-1. Then K22. O kani, K22 man ni siya, di ba? Are you still with me? K22. K22. So kani is K22, kani siya is also K22, di ba? 2 ug 2 man eh, huh? So it should be K1 plus K2. Okay. By the way, murag natay sayop diri, no? Kani 1, 2, 3 man eh, no? According butangan diri, 1, 2, 3. 1, 1, mora ni. 2, 1, mora sad ni. 3, 1, mora sad ni. 1, 2, I think we have this 1, 2 kani. So this should be negative K1, no? This is not 0, ha, kani. So this is sa punto pa ano ni. Okay. Sorry. Sorry. Okay. Negative K1, no? Negative K1. Okay? Yeah, 3, 2. You have 3, 2? Yes, this one, negative K2. Yeah, 1, 3. No, 0. Kani siya is 2, 3. Where is 2, 3? 2, 3. This one, negative K2. Finally, K3, 3. It is K2. So, mo ni karon ang akong stiffness matrix for the entire structure. That is how to combine. Okay? So, again, by looking at this structure, we know that the total degrees of freedom is 3. There are 3 nodes and one degree of freedom per node. So that means we expect that the stiffness matrix of this has a size of 3 by 3. So mao ni siya, no? Okay, instead of going back to the definition, so i-standardize na ni nato, no? So per element, mao man ni siya karon, ako na lang i-combine. Okay, so kindly take note of this. So, diba, kung inyo tong balikon ganiha, naman tagi consider ganiha kani, mao man ni ang atong result, no? Okay, natong force displacement relationship using the definition. Okay, karon ang atong gibuhat is ato siyang combine na siya, no? So kani siya nga standard. Okay, so this is the result. Then you apply the forces. Okay, and you solve the displacements. Please take note that the displacement at point 1 is 0y because this is fixed. Of course, there's no movement on the point 1 because it's a support, no? So you have to apply this boundary condition. It's a restraint. So morning 0, you put the forces here. Of course, your solve na ninimo ang imong U2, U3. By the way, if you take a look at this, kaning row and column, okay, before you solve, the rows and columns that is line from the 0 displacement should be removed para ma-simplify nimo. So gitawag na siya o you have to reduce the size of your matrices, no? So 0 man siya, so I have to remove the rows and columns that corresponds to kani unit displacement kani, na? So 0 man siya, so kani ako ni siyang i-remove kani. So sa may nabilin, kanina lang kani and this one. So from here, ma-solve na nila ko siya. Remember, you can easily solve the stiffness because you have the properties, no, of your elements. Okay. Okay. Okay, let's try an example, another example. Now compute the forces developed in each member and draw the free body diagrams, members, and nodes. Okay. Ipa-analyze ani. So we have the structure. Okay. Again, the requirement here is to analyze the structure. So meaning we are required to determine the displacements as well as the member forces, the stresses of the members. Well, Kanisya, you can again easily solve this using the principles you have learned in mechanics of materials, no, or strength of materials. Okay. So this time, let's solve this using matrices. Right? Now, if you look at this structure, this is a one-dimensional bar. Okay, so this is the axis, no? How many nodes are there? There are 4. 1, 2, 3, 4 nodes, correct? There are 3 members. This is member 1, kani. Member 2, kani. Member 3, na. But there are 4 nodes. So per node, if it's a one-dimensional bar, that's 1 degree of freedom, di ba? Per node. So that makes the total of 4 degrees of freedom for this entire structural system. Okay? So we have to expect that our K, the stiffness matrix is 4 by 4. Okay? 4 by 4 siya, no? Itong K11, K12, okay, K13, K14, sa pilaan, K21, K22, K23, K24, K31, walang usahon na, K32, K33, K34, And last row, K41, K42, K43, and K42. Mao ni ang atong stiffness matrix for the entire structure. Ang challenge na to is kung sama ng value na ko K11, K12, K13, no? And so on and so forth. Okay? So, instead of itong magbuhat na tao 1 unit displacement there, the rest 0, which is again, that's very tedious, no? So, pagtantag siya man ha. So, nga itong gamiton is katong standardized na nga mga stiffness matrix per element, 2 by 2. Okay, then after that, we will just combine. So, expect that there are 3 members. So, tulo ni siya kabuk itong i-combine. Okay? So, ano ni? Member 1, member 2, member 3. So, ganun ani man eh. So, 2 man siya, di ba? Remember, ang atong K is, bilang atong K? E over L. So, ang K1 ako, area 1 po siya, di ba? So, area 1 is 1, di ba? E na ko is 10 times 10 to the 6. Ang length na ko is 10. 10 siya, 10 inches ni tara, no? So, sa may tabo karon, may mo na lang times 10 to the 6 na lang, di ba? O ni dire, no? Ito na ko 1 times 10 to the 5, no? Una, member 2 kay ang area niya is 2 man. Mas ako man ang member 2. So, mo nang 2, nas 2 po ni siya, no? Na member 3 mo ni ang iyang stiffness. Okay? After that, we have to combine. Now, what we will do to simplify, butangan ko nig mga markers. And this siya, member 2 is from node 2 to 3. And member 3 is 3 to 4. Okay? Kung nga rin 4 by 4 man to, di ba? 1, 2, 3, 4. Okay, 1, 2, 3, 4. Ini ako na ni butang sa gawas. 10 times 10 to the 5, no? Para I will be dealing with 1. Kanina lang ang 2. So 1, 1. 1 of 1. 1, 1. So this is 1. Correct? 2, 1. Walay lain. So negative 1. 2, 1. No? Kani o kani. 3, 1. Do we have 3, 1? Wala, no? 3, 3. Walay 1, no? So 0. 4, 1. Wala sad. So 0. Now, next, 1, 2. 1, 2. Negative 1. Walay lain, no? Negative 1. Yeah. 2, 2. Ang 2, 2, duha. Kani o kani. So 1 plus 2, it's 3. 3, 2. 3, 2. Kanira, no? 3, 2. Walay lain. So it should be negative 2. 4, 2. Wala, 0. 1, 3. 1, 3, 0. 2, 3. 2, 3. Asa may 2, 3 karon. Kani, no? Negative 2. 3, 3. 3, 3 is 2. Kani o kani. So 2 plus 1, it's 3. Yeah, 4, 3. 4, 3 is kani, negative 1. 1, 4, wala, no? Wala 1, 4. 0. 2, 4. Wala sa 0. 3, 4. 3, 4. Kani, negative 1. Yeah, 4, 4. Finally, kani siya 1. So this is now our stiffness matrix of the entire structure. So it's actually very simple. No? So yun naging siya kayo. Now, one thing that I would like you to take note also nga, kani siya must be a symmetric matrix. So meaning, symmetrical siya, no? So upper triangular matrix, upper triangle should be the same with the lower triangle. So itong i-check dire. Mo ba ni? Oh. You check this, compare. Ako sa nang i-delete ang uban. The same? Yes, no? They're the same. Oh, 1, -1, 0, 0, no? Okay, basically that's how to set up your matrix, stiffness matrix, right? Now, after that, once you have the stiffness matrix, you set up the force displacement relationship, no? So force displacement, so ang force nimo, this is the K, mao man ang imong force matrix. Okay, stiffness matrix, and you have the displacement matrix, no? So 4 by 4, so there are 4 forces, 4 nodes, di ba? Ang displacements nimo. Now, if we go back to the structure, fix ang iyang 1 of 4, meaning ang imong U1 of U4 should be 0, meaning wala kay displacements. So, what shall we do if we have 0 displacements? We have to remove the rows and columns, no? That corresponds to those 0 displacements. So, mamani, U1 of U4. So, I have to remove first row, okay? First column. And kinesia is 4th row, 4th column. So, nabilin ka rows, kanina lang, kanina, o kanina. So, from here, masolve na nako ang iyang displacement. So, mao na niyang nabilin, di ba? F2, F3, no? So, solbo na ko ang inverse ani to get the displacement here. Mao na niyang result. By the way, F2 and F3, tanaw ni mo diri, no? So, these are applied forces, di ba? F2 is 5, F3 is, this is -10 because this is going to the left. So, take note also of the sign conventions, no? So, if you assume that to the right is positive, then make sure that negative is to the left. Okay? So, it's more or less the standard considerations, no? The sign that if it's to the right, it should be positive. Okay? If it's going to the left, it's negative. Okay. Although you can, if you assume that to the left is positive, just be consistent, no? Okay ra gyapon na siya, no? Again, it's more or less universally accepted that to the right is positive, going to the left is negative. It's the same also. If it's upward, positive, going downward is negative. So, mao ni, pag-reduce na to, so 5, this is -10. So, from here, masolve na kong displacements. So, once I solve the displacements, ako na siyang ibalik din di ba? Masolve na sad nako ang iyang mga reactions. R1 and R4. These are the reactions, no? Kanin din R1 and R4. Okay, so these are the reactions. Then after that, you solve the member forces. Balik ka din per element na to. Remember this? Then you check the free body diagram. So that's basically how to analyze a one-dimensional body. Okay? Ma-check mo ni mo dire, of course, considering per member, and you can even consider per node, no? Free body diagrams. You have this in your strength materials. Okay? That must be in equilibrium. Now, I would like you to try this also using what you have learned in strength materials and try to compare, no, the results. Okay? So these are the free body diagrams, no? Now, do you have any questions or clarifications so far?
Can I ask, sir?
Yes, please.
Katong ano sir ba kay nalibog lang ko sir sa step 2 sir cause you said na i-cancel ang katong rows where katong fixed man siya sir so we cancel row 1, row 4 tapos column 1 and column 4.
Mm.
Tapos sa katong example before sir kay ang na-cancel lagi nato sir kay ang row 1 and ang column 3 sir.
So, again, before, kani?
Katong 3x3 na matrix.
Okay.
Yes sir.
Yes. So, kani, imo ning i-cancel ang mga so kani zero displacement man ni siya, di ba? Sa first row. So first row and first column pagka, no? First row,
Okay sir.
oh. And first column kani, no? No?
Okay. Sorry sir. Thank you sir.
So ang nabilin is kani, o kani, di ba? No? Okay.
Yes sir. Thank you sir.
Sige. So, unang lagi yung buhaton. First ninyo is we have to set up the stiffness matrix. Okay, so that's the basically this is very procedural. First, you set up the stiffness matrix. Okay, then after that, imo na siyang i-reduce by applying the restraint conditions. Ito mga boundaries with zero displacements. Okay, after that, masolve nimo ang displacements. After the displacements, you solve the reactions, the non-reactions. And after that, you solve the member forces. As simple as that. Mao ra ginang buhaton, whether it's a one-dimensional bar or a three-dimensional frame. The only difference here is you will be dealing with large matrices lang. Okay, okay. A three-dimensional frame, for example, so pila naman na ka-kuan, pila naman na ka-displacements, pila naman na ka-degree of freedom per node. So dako na rin siya. No? Yeah, for example, in one structure, there are 10 nodes. So you multiply that by the number of nodes per number of degrees of freedom per node. So, ko na kaya mo matrix. But again, the procedure is the same. No, nagigit na siya. Okay. Now, do you have any questions or clarifications? Ooh. By the way, nagbutang ko assignment sa inyong sa inyong canvas. Okay, so ang deadline na to would be 2 weeks from now. No? So although I know you can submit that earlier, no? If you wish. No? I really thought nga di ko kaklase karon kasi wala mong mitingo ginihag yung buntag. No? So maybe assist na lang to. 2 weeks from now na lang ang deadline na to. So I would like you to let's meet again next week. No? So hopefully we can meet on Thursday. So I'll just coordinate with Camille. Camille, ikaw lang mo yung mga inform sa mga classmates. We can meet on Thursday evening and Friday morning. Any questions, clarifications?
Sir, ang assignment sir ba manual ang pag-solve sir?
Yeah, I think siguro sa kani manual sa siya, no? Okay. Except siguro sa katong manual lang, no? Manual tanan for this.
Thank you sir.
Okay. So Tomorrow gida sana, no? So set up the display stiffness matrix, reduce, and solve the displacements. After that, you solve the known forces. These are the reactions, no? Then you solve the member forces. That's it. Tomorrow gida siya. By the way. Kaya siya sayon lang ni siya kayo. That's why you can easily solve this manually because we are not dealing here with large matrices. No? Kaya one-dimensional bar man siya. 1 degree of freedom per nodrum. Alright?
Ay, sir, kanang sa
Yes.
assignment tayo, sir, ba kay, di ba, sir, ma'am, kuha man may o inverse sa K nga matrix, sir. Kailangan na mo i-show ang step by step also, sir, on our submissions sa inverse sa matrix, sir.
Yeah, pwede rin siguro. No? Mas mayo. No? At least, matrain mo.
Sige, sir. Thank you, sir.
Okay, but anyway, after this, wala ka ng pwede na program ang inyong isubmit, no? In Excel. Okay. So, kani lang siya, at least, makuhaan bitaw mo, more or less, ma-train mo ba, no? So, ang ikuan pa, we should learn how to crawl before we start to walk. Okay?
Okay, sir. Thank you, sir.
Sige, so I think that's the end of my discussions today. So hope to see you all next week.
Excuse me, sir.
Or-
Master.
Yes.
Sa assignment, sir, ba asa ni ang problem 1.1, 1.3?
Ana sa katong textbook na to. So tanan na sa textbook itong assignments, okay? Nasa katong kang Robert E. Sennett na textbook. Ito na nang i-download sa Canvas, no? Okay, so thank you. See you all next week. May buntag.
Thank you, sir.
Thanks, sir.
Thank you, sir.